All right, today we are diving into a really fundamental concept in Java, something that basically acts like the security system for all of your code. We're talking about access specifiers. Let's get right into it.
You know, you really have to ask yourself this question. When you're building a project of any size, you've got to decide who gets to touch this piece of data, who gets to call this method. Because if you don't have that control, things can get really messy really fast.
I mean, just imagine an office building where there are no locks on any of the doors. Anybody can just wander into the CEO's office, start digging through sensitive files, maybe even start messing with the server room. It would be total chaos, right? Well, that is exactly what happens in a software project when you don't have proper access control.
Yeah, we call this code chaos. You end up with bugs from unintended changes, components that are way too fragile, and just a massive headache when it comes to maintenance. This chaos is precisely what Java's access specifiers were built to prevent. They're here to bring order and security to your code.
So, how do we solve this? Well, Java gives us four incredibly powerful keywords. You can think of them as four gatekeepers that we can put in front of our variables, our methods, even our classes, to define exactly who gets a key and who doesn't.
And here they are, our four levels of security: public, protected, default, and private. Each one gives a different level of visibility, a different level of trust. We're going to break down what every single one of these does, starting from the most wide open to the most locked down.
And to make this super clear, we're going to use a simple analogy for this whole next section. Just think of your code as a big company office building. Each of these access specifiers is like a different security zone inside that building.
So first up, we've got public. This is the least restrictive of them all. When you mark something as public, you're basically shouting from the rooftops that it's completely open for business. Any class, in any package, anywhere in your entire program can see it and use it.
So in our office building analogy, public is the main lobby. It's totally open to everyone. Visitors, careers, employees from a totally different company, they can all just walk right in. There's zero security at this level. Okay, next up is protected. Now things get a little more restrictive. This one has two main rules. First, it's visible to everything inside its own package. And second, it's visible to any subclasses, even if those subclasses are in a different package. This is where the idea of inheritance really becomes important. Let's go back to our building. Protected is like the employee-only floors. To get past security, you either have to work in that specific building, which means you're in the same package, or you have a special employee badge from a parent company, which means you are a subclass. Next, we have default access. Now, this one's a little tricky because it's the one you get when you don't type any keyword at all. That's why people sometimes call it package private, and for good reason. It means the thing is only visible to other classes inside the exact same package. That's it, no exceptions. In our building, this is like a specific department's office space. Think the marketing team's floor. You can't get in just because you're an employee of the whole company. You have to actually be on the marketing team. It's all about keeping things within the team. Okay, this brings us to the number one point of confusion for so many developers: protected versus default. Let's just spell it out. They both allow access from within the same package. The only difference is that protected adds one extra rule. It also lets subclasses from outside the package get in. That's it. That is the key distinction. And finally, we have private. This is the ultimate lockdown. This is the Fort Knox of access specifiers. When you declare something private, it can only be seen and used from right inside the curly braces of that exact same class. Nothing else gets to touch it, period. In our building, this is your personal locked office. Not your department, not other employees, and definitely not the public can get in. Only you, the class itself, have the key. And this right here is the very heart of encapsulation, protecting the internal workings of an object so that you can change things on the inside without breaking everything else in your application. Okay, so we've just walked through all four gatekeepers. I know, it's a lot of rules to keep in your head. But the great news is we can summarize all of it perfectly in a single table, what I like to call the visibility matrix. This table right here is your ultimate cheat sheet. Seriously, just look. Down the rows, you've got our four modifiers, going from most restrictive to least. And across the columns, you've got where you're trying to access from. You can see right away that private only lets you in from the same class, while public just throws the doors open to the whole world. This is your go-to reference.
So why does all this matter so much? Well, it really boils down to this core principle of good software design. You want to expose what your class does through its public interface, but you want to hide how it does it by making all the implementation details private. This is what makes your code flexible, secure, and a whole lot easier to maintain in the long run. So what's the practical takeaway for you when you're writing your own code? It's simple. Just follow the principle of least privilege. Here's how it works. When you create a new variable or a new method, make it private by default. Just start there. Only make it more visible, bumping it up to default, protected, or public, if and only if you have a very clear, justifiable reason to do so. Start locked down and only open up when you have to. So there you have it. You now have the keys to your codebase. You understand how to control access, how to protect your data, and how to design much cleaner, more robust classes. The only question left is, how are you going to use them?